Let's start with the physics chapter 2, work, energy and power. What is work? Work is said to be done when you apply some force on a body and the body begins to move. For example, if you push this book, see, I'm applying some force and this book or the notebook has begun to move. But suppose I am pushing a wall in front of me. If I will push this wall, but the wall will not move, it means how much force you may apply on the wall. Since the wall does not move, so the work done is zero. Then is your measurement of work. Now the amount of work done, it depends upon two factors. One is how much the force you're applying and how much is the displacement produced in the body on which the force is applied. And we know it is directly proportional to both. So formula of work is force into displacement. That is, if displacement is 0, S is 0, then F into 0 comes out to be 0. And it is also a scalar quantity. Now another expression for work is W is equals to Fs cos theta. Theta here is the angle between the force and the displacement. When we are not sure that the direction in which the force is applied and the displacement is in the same direction, when we are not sure of that, then it takes the form as W is equals to Fs cos theta. Now there are three special cases, very important. One is the positive work done, zero work done and a negative work done. First we will study about the positive work done. Remember, positive work done the work done will be positive only during when the angle between the force and the displacement, that is theta, is given to you as 0 degree. Now remember, theta as 0 degree means the direction in which you are applying the force, the displacement also happens in the same direction. Let us take some example. Before that, W is equals to Fs cos 0 degree. Cos 0 is 1, that is Fs into 1, it comes out to be Fs, that is work done is positive. Now let us take some examples. First is in a free fall of a body. Suppose this is a ball, it is falling freely under force of gravity. We know that W is equals to F, weight is equals to force is equals to mg, it is acting downwards, and displacement is also acting downwards. So both are in the same direction, so theta comes out to be 0 degree. Let us take another example. When coolie raises the load against the force of gravity. Suppose this pencil is here. I am suppose picking this pencil up. Now you know that how much force I require to pick it up. How much it is its weight? क्योंकि जितना इसका weight नीचे को लगेगा उतना ही मैं force से इसको ऊपर को उठाऊंगा, तभी मेरे से पेंसिल उठेगी ऊपर को. तो अब मेरे पास जो फोर्स लग रही है वो ऊपर को लग रही है, दैट इज mg. और इसकी डिस्प्लेसमेंट भी नीचे से कहाँ को हो रही है, ऊपर को, क्योंकि मैं नीचे से पेंसिल को ऊपर को उठा रहा हूँ. तो बोथ आर इन द सेम डायरेक्शन, हेंस इट इज अगेन पॉजिटिव वर्क डन. Then is your negative work done. But remember, work done is said to be negative if the theta is 180 degree. Theta means the angle between force and displacement is 180 degree. Then it becomes W is equals to Fs cos theta it was. तो theta की जगह पे 180 degree, cos 180 is -1. तो Fs into -1 comes out to be minus Fs. Now let us take some examples. Suppose I am moving this book on the table. We know it will stop after some time. Why? Because force of friction is acting on it. We have done in 9th standard contact and non-contact forces. Since the force of friction is acting on it, it will act opposite to it. Now suppose if I was moving the book this side, force of friction will act opposite to it. It will act in opposite direction. So what is the angle here? 180 degree. Let us take another example. Earlier it was a free fall of a body, that was body was falling downwards. Now what we are going to do is we are going to throw a body upwards. When we throw the body upwards, displacement will be towards this direction, but the weight is equals to F is equals to mg, that will act in downward direction. So it is in downward direction, it is in upward direction, so angle between them again will be 180 degree. Third case is your zero work done. Zero work done, then when angle between the displacement and your applied force is 90 degree, that is W is equal to Fs cos 90 degree. Fs cos 90 is 0, Fs into 0 is 0, so work done is 0. So let us try to understand these examples. I have told you, remember this thing where you say when a coolie walks on a road with the load on his head, we say work done is 0. Why work done is 0? This will read now, understand now. Suppose a coolie is walking on a horizontal ground, beta. So it means displacement is in this direction. But we know, suppose this is its load, then its W is equals to F is equal to mg will act downward. So what is the angle between both of them? 90 degree. That's why work done is said to be 0. Another question, this was asked in ICSE 2020, this year exams, that when a body is moving in a circular path, work done is said to be 0. In the first chapter we have studied, whenever a body moves in circular path, the force required for its motion is called centripetal force. And then centripetal force always acts towards its center. And in 9th standard we have studied, when a body moves in a circular path, its displacement is always tangential. That is this way. This is also its displacement. This is also its displacement. This is also its displacement. And this is also its displacement. So see here, this was force, this is displacement. What is the angle between them? 90 degree. Displacement, force. What is the angle between them? 90 degree. 90 degree again. And 90 degree again. And we know whenever angle is 90 degree, work done is said to be 0. Then is your note. Remember beta, if any time force and displacement time graph is given to you and you are supposed to ask, you are asked to find its work done, then what you have to do is you have to find the area under the curve. Area under the curve means area under the curve and this x-axis. Area under the curve and the x-axis. This area. Suppose the graph is like this, then again area under the curve and the x-axis means this area. This is your triangle, so area of triangle comes out to be half into base into height, this height. And here it is a rectangle, so area of rectangle will be length into breadth. Next is your work done by the force of gravity. Suppose let a body of mass m, any body of mass m, it is moving down, vertically down. It can be a lift or it can be stairs, anything. Then remember, we know that work done is F into S, and here the force is acting downwards, that is its weight, that is mg. So in place of F it will be mg, and suppose that height through which it is moving is h, so mg into h is mgh. But now I'm going to move opposite. Let a body of mass m is moving up, that is against the gravity. So what will be the work done by force of gravity now? M minus mg into h, because g will be negative here. But remember, if that is your work done by the force of gravity on the body, but the work done by the body against the force of gravity will be, that will be again W is equals to positive mgh. On the basis of this, we'll have some numericals in the exercise.